Hello everyone, my name is Emily. I will be discussing bioprinting. During this presentation, I will discuss what bioprinting is, the different methods of bioprinting, and some of the benefits. What is bioprinting? Bioprinting is a technology that allows for the 3D printing of living tissues using bioink. This process is a subset of additive manufacturing, where objects are created layer by layer on digital models. What are bioinks and stem cells? Bioinks are a mixture of cells and biomaterials. This combination allows for the creations of 3D structures that can mimic the natural tissue environment. Stem cells are unique cells capable of self-renewal and differentiation into various specialized cell types. Stem cells can be incorporated into bioinks to create functional tissue constructs. There are 4 different types of bioprinters. The first type is an inkjet-based printers, which is the most common technology used for both non-biological and biological applications. This was originally a technology for 2D printing, but has evolved to print biological materials with impressive accuracy. Custom-designed bioprinters now replace traditional ink with bioinks, but for this to work, the biological materials need to be in liquid form to create droplets, which ends up limiting the types of materials that can be used. The second type is laser-assisted printing that uses a laser to deposit biological materials onto a surface. This technique involves a pulsed laser, a focusing system, and a layer of biological material in a liquid solution. The third type is pressure-assisted printing that involves extruding biomaterials through a nozzle to create 3D biological structures. The printing speed is slower than the rest, but this method allows for processing at room temperature. The final type of printing is extrusion-based, also known as micro-extrusion, which is the most common method of printing non-biological 3D structures. This technique allows for the precise layering of biomaterials. This method is for creating 3D biological structures used for tissue and organ research. What is the process of bioprinting? There are 3 stages to bioprinting: pre-bioprinting, bioprinting process, and post-bioprinting. The first stage involves creating a digital 3D model, which can be done either from scratch or based off scans of the existing tissue. Preparation of bioinks are done in this stage as well. The second stage is when the bioinks are loaded into cartridges and extruded through print heads to form desired structure. And the final stage is cross-linking the structure to stabilize them. Then they are put into incubation in a suitable environment to allow cell growth and tissue development. Some benefits of bioprinting are that it can bypass the shortage of organ donations. Many people wait for an organ transplant or are even waitlisted. Bioprinting organs can allow a supply for people that need an organ or are waitlisted. Bioprinting can also assist with tissue repair. When someone has burns that are too much to repair or the patient may not have enough skin to cover the area, bioprinting can assist with this and create the tissue needed. Also, bioprinting will replace animal testing. Animals testing for medication or medical experiments can be stopped since we know that in bioprinting animals will react differently from a human. Some challenges of bioprinting is the speed of bioprinting, since some printers tend to work slower than others, but the accuracy of the organ has a higher rate. Secondly, there isn't a wide spectrum of biocompatible materials, which puts us in a situation where not all organs can be printed due to supply of biocompatible materials. Then there's the conversation of ethical issues. Many will disagree with bioprinting since it brings the topic of human enhancement and these organs being created for greater efficiency. Finally, the cost of bioprinting. There hasn't been an amount set, but with all taken into consideration, the cost can be an issue since there isn't many compatible biomaterials. Future predictions. As bioprinting technology evolves, we can expect innovations that will enhance the precision and functionality of printed tissue. We could also create customized tissues for individual patients tailored to their specific medical needs. Bioprinting represents a significant advancement in biomedical engineering, with the potential to revolutionize how we approach tissue regeneration and organ transplantation.